the neuromuscular system by talking about something called the bilateral deficit. Many of you have probably heard about this in taking classes from Trevor, I believe in 218 or 219. So I just want to talk about it for just a minute. It's a really interesting thing that happens. So we've got just two objectives and outcomes for this. And so the bilateral deficit, if you're looking at like a textbook definition, and please do not give this to me on an exam, because this just, again, shows that you can copy words as opposed to actually tell me something in your own words. But it's the inability of the neuromuscular system to generate maximal force when two limbs are operating simultaneously compared to when they operate individually. Okay, like what in the world is this actually saying? Well, what it's saying is that if you do a movement with both arms or both limbs, so both of your legs or both of your arms, that when you do it together, that's actually going to be less than what happens if you add up the individual sums together. So for example, if you do a chest press, and let's say with your right arm, you're able to do 100 pounds, and then with your left arm, you're able to do 100 pounds. But when you do it together, you're not going to hit 200 pounds. You actually might only hit 190. And so this is why we call it a bilateral deficit. The total you can do with both limbs is less than the total you could do with each individual limb. Okay, so what causes this? And that's the thing, is we really don't know. Okay, and just before I go any further, that's what this figure is trying to show you here, is that when we do it unilaterally, so whatever it is that we're doing, I don't know what this figure is showing, that each arm was doing 60 for a total of 120. But when they did it together, each arm is producing about 50 pounds of force, or 50 newtons or whatever, and it's only 100. Okay, so together we're doing less than what we could do if we add up our individual efforts. Okay, the most likely cause is reduced motor unit activation. Okay, and so let's just say that in order to produce 60 pounds of force when you're doing a chest press, that you require recruitment of 60 motor units. That just makes it easy. So we've got 60. We recruit 60 motor units when we did it on the left side. We recruited 60 motor units when we did it on the right side. Okay, so each trial, we're only recruiting 60. Now let's say though that your brain, your nervous system, is only able to activate 100 motor units at any time. Okay, regardless of the reason, let's just say that's what it is. Well, in order to do 120, we'd have to recruit these 60 and these 60, which is 120, but my max is 100, we'll say. And so as a result, we don't recruit as many motor units. And ultimately, this will lead to reduced power production because I'm not recruiting as many motor units, less cross bridges, less power, force production. Things are actually going to happen slower because we don't have as many cross bridges, don't have as many muscle fibers and all that. And another thing is that this can also cause decreased coordination. Okay, so really it's not completely understood what causes it, but this reduced motor unit activation is the most likely cause. I've also heard it described or hypothesized that it might be from a safety issue, right? If you're giving all out, you're producing more power, more force, you're more likely to succumb to injury. I'm not sure if that's the case. I tend to believe the reduced motor unit activation theory.